Okay, imagine getting real insights into your skin health. Like, is a wound healing okay? Is there an infection maybe starting up?
Or even how well your bug spray is working.
Exactly. And getting all this info without anything actually, touching your skin sounds a bit sci-fi,
It
right?
does, but it's actually happening now.
Well, get ready, because today we're diving deep into this really groundbreaking new wearable device that's making it a reality.
Yeah, we're looking at some incredible tech developed by researchers over at Northwestern University. And this isn't just a concept. It's been published in Nature, the journal, and importantly, tested successfully on animals and on people.
So for you listening, our mission today is pretty straightforward. Break down the science, explain why this thing is such a potential game changer, and what it might mean for personal health monitoring.
Think of it as your shortcut to getting up to speed on this.
Definitely. And the core idea, it's this totally new way to understand what's happening with our bodies by looking at the gases our skin gives off and takes in.
Exactly. It taps into this constant conversation our skin is having with the environment through gases, information we just couldn't easily get before, not without being invasive anyway.
Okay, let's unpack that. So what is this device? Can you describe it a bit? What's it actually measuring?
Sure. So fundamentally, it's the first wearable that can measure both gases released from the skin and gases absorbed by the skin.
Both ways. Oh.
Yeah, the full exchange. It's packed with tiny sensors measuring temperature, water vapor, H-Euro, carbon dioxide, Care Euros, and also various volatile organic compounds, VOCs.
And the really clever part, you mentioned it's touch-free. It hovers.
That's right. It's designed with this small chamber that sits just slightly above the skin surface. No direct contact.
That seems like a huge plus. You avoid irritation, especially on sensitive skin.
It's a really significant advantage, yeah. Especially for, say, monitoring damaged skin or burns, or even on newborns where any contact could cause issues or risk infection.
Makes sense. How big is it?
Oh, it's tiny, about 2 centimeters long, 1.5 wide. Inside that little package, you've got the chamber, all the sensors, a programmable valve, which is key,
A valve.
plus the electronics, and a little rechargeable battery.
And a programmable valve in something hovering over my skin. You have my full attention. How does this little gadget actually work? How does it figure out what my skin's doing?
Okay, so that valve is, it's really the crucial innovation here. What it does is it periodically opens up for a moment
To do what?
to get a baseline reading of the ambient air right around the device, the normal air.
Okay. Samples the environment first.
Precisely. Then, snap, it closes,
Yeah.
seals off that little chamber, trapping any gases being released by the skin or being absorbed into the skin right there in that contained space.
Ah, so it creates this tiny temporary microenvironment right above the skin to analyze.
You got it. And once those gases are trapped, the sensors inside measure how the concentrations change over a short period. It's dynamic.
Why is that dynamic part so important?
Well, the researchers point out that without that smart valve, the device might just pick up random changes in the air around you. You know, maybe someone walks by wearing perfume or the ventilation changes.
It could get confused.
Exactly. The valve lets it specifically isolate and measure the changes happening right at the skin surface, distinguishing them from just background noise.
That makes a lot of sense. So if you were, I don't know, painting a room, it could tell the difference between the paint fumes in the air and what your skin might actually be absorbing.
Precisely. Which, as they note, could be really important for, say, workers in environments with hazardous chemicals, understanding skin exposure.
And it sends this data somewhere.
Yep, wirelessly. Uses Bluetooth to send it all to a smartphone or a tablet, so you can get real-time monitoring.
Real-time skin updates on my phone. Okay, that's pretty cool. So we know what it is, how it works, but the big question is why? Why does this matter? What can we actually do with this? Let's start with skin health itself.
Okay, yeah. One of the biggest potential areas is wound healing. By constantly tracking water vapor, KYO, those VOCs, doctors might be able to spot infections or problems with healing much, much earlier than they can now, like before it's visually obvious.
Which could cut down on just guessing if antibiotics are needed.
Exactly, which is a huge deal with antibiotic resistance being such a massive problem. Knowing for sure if an infection's brewing, instead of prescribing just-in-case antibiotics, that could be huge.
A real game changer for fighting superbugs, potentially.
Absolutely. And it looks particularly promising for patients with diabetic foot ulcers.
Oh, right. That's a serious issue.
Huge. Professor Amir, one of the lead researchers, he highlighted this. These ulcers are a major reason for lower limb amputations worldwide, the non-injury kind.
Wow.
So this device could give crucial info about how well the skin's barrier is working in those patients, even if a wound looks like it's closed up on top. It might help prevent some of those really devastating outcomes.
So it's like getting X-ray vision for skin function, seeing problems before they fully emerge.
In a way, yeah. And it actually builds on some of Professor Amir's earlier work with Professor Rogers on that electronic bandage for diabetic ulcers. This feels like a natural next step.
Makes sense. What about the skin barrier generally? We hear that term a lot.
Right, the skin barrier. It's that outermost layer, the stratum corneum. Think of it as like your body's first line of defense.
Keeps the good stuff in, bad stuff out.
Pretty much. It locks in moisture, keeps irritants, allergens, bacteria out. When it's damaged, you lose more water. That's called transepidermal water loss, or TEWL.
TEWL. Got it.
Right. And that damage also means you're more vulnerable to irritation, infections, inflammation. Things like eczema can flare up.
And measuring this TTDUL thing, that's usually tricky, isn't it? Involves bulky gear.
Very tricky. Yeah, the current gold standard uses these relatively large probes that have to touch the skin, and you only get snapshots, intermittent readings.
Not ideal.
Not at all. So this new device, it can measure TEWL continuously and remotely. That's a massive leap forward. Imagine monitoring someone's skin barrier health 24/7, even while they sleep, without disturbing them.
That continuous remote aspect really does sound like a shift towards more, well, personalized and proactive care. You mentioned the touch-free part being good for sensitive skin, too. Why is that so key?
Well, think about newborns, especially preemies, or the elderly with very fragile skin, or people with severe burns or conditions like epidermolysis bullosa where the skin is incredibly delicate.
Any touch could be harmful.
Exactly. It could cause pain, damage, infection risk. This completely avoids that, making it much safer and more practical for monitoring these really vulnerable populations.
Okay, so beyond wounds and general skin barrier health, where else could this tech go? What other applications are they thinking about?
Oh, it branches out quite a bit. For instance, think about cosmetics or dermatology, evaluating how well topical products, lotions, creams, ointments actually penetrate the skin.
So you can really know if that expensive face cream is doing anything.
Potentially, yes. You could get objective data on skin permeability and how a product affects the barrier function by measuring those gas exchanges.
Interesting. What else?
Well, developing better transdermal drug delivery systems, patches and things.
Right.
This could help optimize how drugs get through the skin and also monitor the effects of drugs taken systemically, like pills, on skin conditions. Plus, the cosmetics industry could use it for safety testing, too.
Okay, and you mentioned bug repellents earlier. That cut my ear. How does that work?
Yeah. So it turns out mosquitoes and other biting insects are attracted to the Kyoto and specific VOCs we release from our skin.
That's why they find us.
That's a big part of it. So by measuring these specific emissions, scientists could figure out why some people are mosquito magnets and others aren't.
Finally, an answer?
Potentially.
Yeah.
And that understanding could lead to, better repellents or maybe even ways to make ourselves less attractive to them in the first place.
That would be amazing. Okay, looking ahead, are the researchers planning more upgrades? What's next for this device?
Definitely. The team's already working on refinements. They want to add a sensor for pH levels, another important skin health indicator.
Fair.
And perhaps even more exciting, they're developing gas sensors with much higher chemical selectivity. The idea is that maybe, just maybe, they could detect specific gas signatures linked to organ dysfunction or other systemic diseases really early on.
Wow, so going way beyond the skin.
Yeah.
Detecting internal issues through skin gas. That's ambitious.
It is, but it shows the potential scope. It's fascinating to hear from the inventors, too. John Rogers, one of the pioneers in this whole field of biointegrated electronics.
What did he say?
He described it as a natural evolution from their earlier work on sweat analysis. He stressed that skin emissions are happening all the time, naturally. You don't need to induce sweat.
Right, it's continuous data.
Exactly. And he sees this fitting into a bigger picture of non-invasive continuous monitoring for truly personalized care.
And Guillermo, you mentioned his focus on diabetic ulcers.
Yeah.
What was his main point?
He really emphasized that this is a completely novel way to assess delicate skin without contact. For him, the big impact is transforming care for those vulnerable groups, newborns, elderly, burn patients, getting objective data without causing harm. That's the core value.
Makes sense.
Yeah.
And Amy Paller, the dermatologist on the team.
She hammered home the importance of that skin barrier and how significant it is to finally be able to monitor TEWL remotely and continuously. She sees it as a major advance for dermatology, moving beyond those cumbersome, intermittent hospital measurements.
Okay, so if we boil it all down, what are the key takeaways for everyone listening? What should they remember about this tech?
I'd say first, it's non-invasive monitoring, no contact needed. Second, potential for early detection of problems like infections or poor wound healing. Third, the remote capability opens doors for telehealth and personalized care plans.
Right.
Fourth, it has really broad potential applications from testing your face cream to understanding bug bites, maybe even future disease detection. It's not just about skin in the long run.
So wrapping up our deep dive then, this touch-free wearable analyzing gases, it really does seem like a revolutionary approach to understanding skin health.
It really does.
And it feeds right into that desire we all have for knowledge, quick insights, but deep ones too. Those aha moments about our own bodies and health.
Definitely. And it leaves you wondering, doesn't it? It raises this kind of provocative question to mull over.
What's up?
Well, what other secrets about our health could be hidden in the gases our bodies are constantly releasing and absorbing? And how might this kind of continuous, totally non-contact monitoring really reshape preventative health care down the road?
That's a big question, analyzing our personal atmosphere.
Exactly. It's a fascinating frontier, and this Northwestern device is clearly pushing right into it.